This is a demonstration on how to test a tube on the valve characteristic meter type VCM 163. I'm going to go over a couple of basics first before we test any tubes. And the first thing you want to notice here over on this meter is this needle is sitting right on the line inside of the green. And what that means is down here where you have the line set, we have adjusted it so that it is within the range. Now let me show you. If we turn it back, we're now going to see that the needle is sitting just on the outside edge of the green. I'm going to go back the other way, and now we're beyond the green. So you want to be on that green with needle set, and over here circuit selector set at cold. This is your insulation test over here. So we now know that we're okay. So the next thing you want to do when you first get this tester, you don't have to do this all the time afterwards, but we're going to go ahead and do a calibration check. And we're going to see if we are on the line over here for calibration, and we are. We're sitting on that line. Now once you get this tester and you see that it is above or below the line, and again you might need to go back and forth a little bit just to make sure that you're sitting there on that line. If you're not on that line, you want to come over here and look at the side of the tester, and you will see a silver button over here. Now you pop that out, and then you will see an adjustment pot, and you want to use a thin blade screwdriver like this. Anything fatter than that, and it's going to catch on the twines that keep that pot from moving. So put that back and you're ready to go. So that's preliminary. So we're going to go back to where we were to the beginning. Now what we are going to be testing here is basically a 12AX7. It happens to be a Mullard, and we're going to come up here and look at the selectors. And these are the selectors that are chosen or taken from the data manual for this tester. Now there's two manuals. There's one that is specific for this tester, and there's another one that combines it along with all the other testers that are the VCM types. Now the problem is that they're errors, so you want to make sure. On the AVO original one, we have the settings correct. On the combination one, they're not correct. So if you want to double check to make sure yours is printed correctly, just go up the page a little bit and find 12AX7. From there you want to go up the page and find 12AU7 or AT7, and the selector numbers should be identical to those tubes because they are. They simply are. They're the same numbers. If you use the other numbers and it's not this setup, the tube is going to sit there and it isn't going to do anything. It'll be stone cold. Okay, now we're going to go on to the testing procedure for this. The other thing I want to mention before we go on is over here on the milliamp per volt meter, which is basically, you want to call it the GM meter. That's fine. You will notice that it's sitting on the very first division mark. That's not unusual. In fact, even on the second mark, it's not unusual when we're sitting here stone cold. Sometimes it'll be on 0, and sometimes it'll be on there, and sometimes it even might be on that second division. And what you're actually picking up is interference in your home, from a radio station, from an air conditioner. You're picking up radiation, and it really is not relevant once you're testing the tube. It is canceled out, so don't be alarmed if you see that needle sitting there like that. It's nothing that you can do anything about. Even though they've got protection inside with shielding and everything else, it's so sensitive, it still picks it up, so just ignore it. Okay, we're now going to start with how do you test this tube. This is a 12AX7 that we have in here. And we have the electrode selector, and we're going to be on 1. That's the number 1 anode for this tester, the first element. Over here we have the voltage according to the setup chart, which is 250 volts. There's no screen, so it really doesn't matter where this is setting. The next thing over is your grid volts, and it says we're supposed to be at 2. So we're going to set the knob here from whatever it happens to be, back to 0 and 3. And on the inside vernier of this dial, you will see 3. 0, 1, 2, 3. So we're using that inside dial. And it might call, another one might call for 1.3, in which case you would measure up to the 1 and then to the smaller divisions for 3 and get 1.3. So we are now set up for our grid volts, we're now set up for our anode volts, and now we want to see our heater volts. Now again, I will go back to these two different manuals. The first manual for the AVO had this tube at exactly 6, not 6.3. The later edition with the mistakes has it at 6.3. I've done both, and I don't see a whole lot of difference between the two. In fact, I'll even show it to you. So right now I'm going to go back to 6.0. Now we're going to test the tube. The first thing we're going to do is we're going to check for the insulation on all of the internal components of this tube cold. That means nothing is applied to it. It's cold, except for basically an ohm meter is going to check it. And we're going to go turning this leakage switch one division at a time, and we're going to see if we pick up anything along the way. Now the first one, once you get past the voltage selector switch setting, which is here, and it corresponds with the little wiggly line, which is your sine wave, and right there. The first one is testing whether or not you have continuity on your filament, and it is a short basically, and by golly, yes, it is showing that it is a short, so you have filament continuity. Now let's go on around and see if we have any other internal shorts or leakage through the insulations. And no, we don't. We're right back to it. Now, we just tested the first element in that tube. Now we're going to test the second anode. So we're going to turn it up to A2, and we're going to do the same thing again. Is this heater good? Yes, it is good. And we're going to go on around and see if the insulation on all the other components are good, and they are. We're right back to line set. The next thing we're going to do is we're going to check this tube with the heater. We're going to warm it up, and once it gets warmed up, we're going to find out if there's any inner leakage once the tube is hot. And if there is, we're going to see it on this meter, and this is the scale you're going to see it on. This is short all the way over to 25 million ohms. Anything in here, depending on what you're using it for, is negligible. Forget it. If you're way over here, if you're using it for like FM or AGC or something like that, sometimes if it's over in here, it can make a difference. The reason it's here is for television sets more than anything else, and it's not so much for audio. If you find out that you have something over here, you might, for a preamp tube, you might have a little noise. Maybe you won't have anything at all. If it's over here, I don't know. I don't know how I'd use it on a preamp tube. If it was a power tube, I would not use it at all. If it's over here in the 500,000 to 250,000 ohms, here you have the here you have the 1 million ohm mark right there. Here you have the 2.5 million ohm mark. On a power tube, if you're in this area, yeah, you might want to use a little caution, particularly if it's a high-powered amp or a guitar amp, because they can be very stressful on a power tube. But we'll go into that once we get into a power tube on this tester. But right now, we're just concerned to see what we've got going on over here. So the tube should be hot, and I'm going to go back over here to anode 1, and we're back down here to the leakage switch, and we're going to go through it. And let's see if we have any leakage anywhere. And no, we don't. We're all the way back to the line set mark for anode 1. Now we're going to go up and do anode 2 and go through the same procedure all the way around, one at a time. I wouldn't do it too fast, just do it one at a time, and we're all the way back to the line set again. So that's good. Now we're going to test the heater-cathode relationship and see if there's any particular heater-cathode problem. And so we go to heater-cathode, and over here we're showing nothing at all. And we're going to come back down to anode 1 And again, we're showing no leakage at all whatsoever. Good, good, good. Now this tube, we're now going to go and we're going to hit the test mark. Now, according to the AVO setup diagram, we should be seeing on a new or average new tube, we should be seeing 1.6 over here. Okay, there's your 1, there's your 1, there's your 5, and then go 1.6. So we should be seeing this area right here as a new tube. Now, anything in this area still is considered a new tube. In fact, AVO is one of the few companies that considered 50% of that new value as still being viable, but I guess it also depends on what you're using it for. But right now, we're just going to be concerned with exactly what they say. 1.6 milliamps per volt is your GM, 1.6. And they're also saying on your current for the tube, and we're sitting over here on our current scale, we are down at 3 milliamps. That's this bottom scale right here. This is 1 milliamp, 2 milliamp, 3 milliamp. Even though it says 30, there would be 10 for that scale. There would be 30 back to this scale. 100 would be back on this scale. Just drop the zeros. It's not complicated. Here we go. So we're sitting on the 0 to 1 milliamp, excuse me, 0 to 3 milliamp scale. So we're going to hit test now, and let's see what we get out of this tube. Well, this tube's quite powerful. That's quite powerful. We're not just at 1.6, but we're basically sitting up here at 1900. Okay, we're sitting up here for a GM value of 1900, and over here, AVO says 1.2 is new, and we're sitting at 1.6 milliamps. That's excellent. That's a really strong tube. Now, where would you use this tube with such strength, particularly over here in the GM? Well, if you have a moving coil cartridge and an audio setup, it would be a great place to have it, because not only would you have the signal strength, but you'd have the current strength. It would be a great place to have that tube. Let's see what we're going to get on the second anode. Let's see how well balanced this tube is. And by golly, this tube is excellent. Oh, Mullard, clap. Let's give a hand to you. We're sitting at 1900 for the GM, and we're sitting at the same basic point over here for the current, which is just slightly under 16. It's hard to see with the needle and the reflection coming from the lights above. So now we're going to come over here and test for gas, and let's see. We're going to see on this scale here, once you go over to the gas scale, you're going to be using this top scale, and it's going to represent microamps now. This is microamps now, so gas. Let's see if we got any. And we're not showing any gas on the second anode. Let's go over to the first anode, and we're not showing any gas there either. This is a fabulous tube. This is a really fabulous tube. So I'm going to come back here all the way to 0 and take this tube out. And let's put in another one and see what we get. And this is an Australian milliwatt tube that I'm going to put in here now. Let's see what we get on it. Basically, it's also another Mullard company, but it's Australian made, and we're going to see what we get on that. So, okay, we're right back to line set, and it looks perfect, no problem. Let's go up here and do that quick cold insulation test. We're good. Go up to here, anode 2, and we are going to go to filament, and that's good, and all the way around, and we have nothing for cold insulation. So I'm going to go back to anode 1. We're going to go up here to heater, and we're going to give it a couple of minutes here to go ahead and heat up. Make sure when you set your tubes up, I don't care how many times you've tested anything on this tester, or any other for that matter, double check what you've got set up. You just never know. One mistake can take out a tube in 30 seconds, or at least wreck it bad enough so, you know, if you're talking about a $50 or $100 tube, you certainly don't want to, you know, destroy the tube because you were overconfident and had the wrong number set up on it. So double check everything. It's not that hard, not that inconvenient. The last thing I'll say here before we go on and check this tube is, again, we're back to what the AVO had originally set up for this tube, which is 6 volts at 0. So 6 volts even, not 6.3. And we're going to go ahead now and test it for insulation while it's hot. And we have no leakage on the internal insulation. Let's go up to anode 2 and see if we have any leakage. And we do not have any insulation leakage. So now we're going to go up to heater cathode. Next one up. And let's see, do we have anything over here that shows? No, we're beyond 25 million ohms. That's nothing. Let's go down here and test the other side of the tube. Still nothing. Now we're going to come back over here and we're going to test the tube actually. And let's see what we've got. Okay. So this is a used tube, I will tell you that. And what are we reading? On the first anode we are reading 1400. 14, there's your 1, there's your 15 at the taller of the short marks. And so we got 1, 2, 3, 4. There you go. That little mark right there is your 1400 mark. And what do we have over here for current? We've got you need to look straight onto the needle. And we have 9. Even though it's offset with this camera, it's showing 9. That's still very good. Let's go up and test the second side. The second side is just slightly stronger. It's still a good tube. We're sitting at 1500 and we're sitting at 1 milliamp output. Now I mentioned this earlier. Let's go and see what would happen when we take it to 6.3 and see how much of a difference we have. You see, there's virtually no difference. There might be there might be one division on the top line, maybe a quarter of a division here. Let's call that 1.2. And over here we have basically the same. We have 1500. So it does change it a little bit, but not dramatically. Again, I don't know what to tell you. Why AVO had 6 on the original document, 6.3 later, I don't know. It's your choice. I guess I would use 6.3 because that's what everybody else uses. And when you do, you will get a number that is slightly higher. Here we are, 1500, and just slightly, almost 1, oh dear, how do you say this here? 10.05 over here. Okay. Now we're going to test for gas, see if we have any in this tube. Again, this tube is used. We're not showing any. We're going to come and turn back to the first anode and see what we got there. And we're not showing any gas either because that is the gas scale. The very top scale is microamps, and this needle would have gone somewhere if there was any leakage whatsoever, and there's none. So this is still a wonderful tube, a very, very good tube. And we're going to come back to here, and now I'm going to end this video and set up for a power tube.